So this is just a 15-minute talk about something I'm really passionate about, so I'm not going to rambling. There's a lot to cover, so I want to get straight into it. The title of this talk is Best Practices for Secure Capability Management and Upgrades. So these are certain things that take place after you've implemented your smart contracts. So suppose you're building some smart contracts, you are done with the implementation, you've done the unit testing, you've done the end-to-end testing, you've done the audits, everything is ready, the front end is ready, the back end is ready, and now you want to publish the smart contracts for production. And you expect that maybe if it's a DeFi smart contract, eventually one day, a lot of value might be stored into it. So you need to make sure it's safe. So you intend to do that, you open a new terminal window. By the way, I'm using white terminal backgrounds because I know it's annoying to everyone. But anyways, so normally during development, you're using the Sui client publish command, either to deploy it on mainnet or testnet for testing or prototyping. But when you're doing it for production, maybe it's not really a good idea. Why? Because the private key that it will use is stored plain text on your hard drive. So if you get a malware, it can get leaked, or if your hard drive gets broken, you lose access to it. So this is not a good idea. So we think, okay, what can we do better? Well, everyone knows about the hardware wallets. So let's try to see if we can use the hardware wallet to store, to publish the smart contract and store the upgrade cap there. Well, here we run into the first obstacle, which is how do you actually use the Sui client publish command, which you use to publish the smart contracts, to work with the hardware wallet. Because if you just connect your hardware wallet, it will not pick it up. But luckily, there's this really useful serialized unsigned transaction flag that instead of executing the transaction, it will just print out this serialized transaction in your CLI. You can copy this, and there's this really handy tool built by Misten Labs. It's called Sui Multisig Toolkit. I want to point this out because I don't think too many people are familiar with this. It's really useful. So you can copy this string, connect your hardware wallet, paste into it. You can dry run the transaction, check that everything is as it should be. And when this is a web app, so when you execute the transaction, it will ask you to sign it, and you can use your hardware wallet to do that. So this is a better way to do it, obviously, because on the hardware wallet, the private key is not going to be ever exposed, and the transaction signing happens in a trusted execution environment. So this is much safer. So in this setup, we have our hardware wallet. It comes with this really annoying seed phrase, which you usually store on a piece of paper. So this is annoying because this seed phrase is another thing you have to manage. Usually you will, keep it somewhere hidden around your house, or I don't know. So this is not ideal. Again, it can get stolen, or you can lose it, or I don't know, if there's some kind of accident, your house burns down, there's a flood, and both your hardware wallet and your seed phrase get destroyed at the same time. So this is much better already than just using some private key that's unencrypted, but it's not ideal because there's still a single point of failure. We want to avoid that because, again, there might be a lot of value locked in these smart contracts one day, and you want to do it well straight from the start. So, but then we go back to our white terminal window, which is really annoying to everyone. And think, okay, we're back to the drawing board. We know that just using straight up client publish is not safe. Using a single hardware wallet is much better, but it's a single point of failure, so it's not ideal. But then we remember Sui has this thing called a native multisig. A native multisig is basically this address that you can create, is sort of a special address, where you can keep your assets on, and in order to use the assets associated with that wallet, you will need to sign it with multiple different private keys. So either hardware wallets or any kind of wallets that you have. In our case, obviously, we want everything to be super secure. So we're using hardware wallets. So in this setup, say we're going to create a multi-sig address that's going to consist of 4 different hardware wallets. And we can also set a threshold. So we can say, we don't have to necessarily require for all the hardware wallets to sign. We can say it's enough for either, say, 2 out of 4 or 3 out of 4 of the wallets to sign it. So this is obviously much better than having a single hardware wallet. So we solved the problem of having a single point of failure. Because in this case, even if one of the hardware wallets gets misplaced, someone steals it, or it gets destroyed, or it breaks down, we can still have access to our object caps and our admin caps that are associated with the multisig, because that's the way we set it up. And another really cool feature of the native multisig on Sui is that signatures are transparent. So when a transaction gets signed, say in the case of 2 out of 4 multisig, we'll be signing with 2 hardware wallets. We will know specifically which exact hardware wallet signed it. So normally you will have the hardware wallets be held by different members of your team. So you know if someone loses it or someone tries to use it maliciously, you have kind of a way to audit and trace it, what happened. And then another thing, this is more of an advanced thing. When you have multiple hardware wallets on your multisig, I would say at least 4 or 5, you can do this really cool thing where you destroy the seed phrases, because we don't really need them anymore, right? Because, I mean, the seed phrases are used in case something goes wrong with the hardware wallet and you need to recover it. But in this case, we have solved this problem by redundancy, by having multiple hardware wallets that are distributed. So we don't really need the seed phrases. Even if one of the hardware wallets dies, we can still manage it and create a new setup with a replaced hardware wallet and move all of our assets there. But here, the important thing is to do a periodic liveness checks. So every month, if you're running a multisig like this, every month or so, every 2 months, it's a good idea to do a test transaction to make sure that all the hardware wallets are functioning correctly. So in case one of them breaks, you can detect it in time and replace them. So so in the case of 2 out of 4, a multisig, for example, you would have to have 3 of them fail at the same time for this thing to break, for this setup to break, which is a very rare thing to happen. And then another thing I want to talk about is the human factor, and I think this is often overlooked because most of the time we talk about technical things, but actually there's a much higher probability you will make a mistake due to a human error rather than a technical error. So when you're doing any kind of changes that require you to sign transactions with your multisig setup or similar, so this is like something very sensitive, I would do like a mindfulness check, because you know something could be happening in your life. I don't know, your girlfriend is breaking up with you, your wife is leaving you, you're stressed for some reason because you're like pushing some deadlines and you're tired, and that's when you're gonna make a mistake. So do a little bit of a mindfulness check. If you recognize yourself in any of those pictures, I mean, you can do it another day, take a nap or something, take some rest, make peace with your wife, and do it then, when you're focused and energized. And another thing I find really helpful is to have a to-do list, because a lot of these changes that you will do can be very complex. It might not be just one transaction that you need to sign. There might be multiple. And you might have an SDK published for your app, and then when you do an update or a config change, things need to be in sync. You need to make sure your backend and frontend are in sync, so your app doesn't go down during the process. So make a to-do list. The first time you do it, the first or second time or third time you do it, you might do it well and you think you know everything. But after a while, you will start forgetting things. So make a to-do list, and then every time you do some sort of configuration change with the admin caps, just go through it. It's going to save you potentially a huge headache. So the next thing, a practical thing, often in production smart contracts, or when you're running a production app with smart contracts, you will need to do some permissioned action that needs to call some smart contracts in a permissioned way. So say you need to, for example, in our app, we're doing rebalancing of the votes or the position. This is a permissioned action that it's not safe to allow just anyone to do it, but we still need to run it, and we need to run it periodically. So in this case, you will be running a backend service that will obviously need to have access to some private key to sign the transaction. So the first thing to point out here, a really good practice, is to use an ACL smart contract to control the access and make sure that the service or the private key associated with the service that's going to do this action is only allowed to do that one specific action that it needs to do. So you're not gonna just have an admin cap with full capabilities on there. You need to limit it in some way to allow it to just do that one specific action. And you can do that with an ACL smart contract. That's a topic on its own. There's multiple different ways to do it, and there's some open source examples of how to do it. But that's a bit out of scope for this talk. And then another practical thing is that when you have private keys associated with some backend services, it's a really good idea to use a key management service. So like on AWS, you can use AWS KMS, or there's this other one called HashiCorp Vaults. You can think of those as hardware wallets for the cloud. So it's similar to a hardware wallet in a sense that the private key is never exposed, but this service runs in the cloud, and the transaction signing will happen in a trusted execution environment. But again, it's not the same as hardware wallet, obviously, because you need to, you call it with an API call, and then you need to protect those API calls with permissions to make sure only your backend can call into that, and so on. But these are the two tips I would have there. This is a common pattern. You need to run some permissioned action periodically. Obviously, it needs to run on a long-standing service. You cannot verify each of these transactions. It needs to be automatic. So in this case, use an ACL smart contract to limit the permissions for this service that's going to run it with an ACL smart contract, and also use KMS to make this private key even safer. So this is pretty much it. These are kind of the takeaways. The gist of it is basically use the KMS, use multisig, use hardware wallets, have a to-do list, do a little mindfulness check to make sure you're very focused when you're doing that, to make sure you're avoiding some human errors. Use an ACL smart contract and KMS if you're running long-standing services. Obviously, as I said, using a single hardware wallet, you can get away with that. I would say it's not the best idea. It's still better if you don't have another option. But at least in that case, also try to get 2 hardware wallets and do a little multisig in case one fails. And obviously, some bad ideas, like never use things like ZK login or browser extensions. I know that like ZK login, it's really talked a lot about these days. but it's not safe for like storing your operator caps and admin caps, obviously, for many of the reasons I mentioned. Also, try not to travel with your hardware wallets. If you have multisig, you can have them with your team. And if you have to travel for a conference or something, then just have the team sign it. So you don't have them, exposed. So that's it. Thank you so much.